This is a Java demo for PriorityQueue. We know that a queue follows the first in, first out algorithms, but sometimes the elements of the queue are needed to be processed according to their priority. That's when PriorityQueue comes into play. The PriorityQueue is based on priority heap. What you see here on the right side is the Java architecture, illustrating how interfaces and class PriorityQueue, in this case, how they are organized. On the very top, you have iterable. This interface allows you to iterate through a collection. This is the reason why collection interface extends iterable interface. So collection interface is also a parent to queue interface. So we went through pretty much all of the above. PriorityQueue is a class that implements queue. So this PriorityQueue basically has everything from functionality standpoint, what a collection has, and also like iterable interface has. PriorityQueue has all of that. This is our PriorityQueue examples that I am trying to illustrate. So let's just say if you start up with an empty PriorityQueue. Let's say if you wanted to order your elements by their natural order, A, Z, B, right, so on and so forth. These are string. So natural order for string is A is less than B, dot, 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 which is less than Z. If your priority queue has the sense of ordering, when you insert something into a priority queue, by the way, this insert is called add. You have A. If you do Z and then insert B, eventually you're going to have A, Z, B, right? So in that order, priority queue is just like queue, first in, first out. Even though the content looks like this, we're just trying to remove the max element out of this one. And since the max element in the natural order is Z, Z is removed. So you ended up with A and B. If you do X and C and so on and so forth, you remove max, and now max is X. I'll give two examples. First, I'm going to create an instance of PriorityQueue. PriorityQueue has a couple of important basic operations. One of them is called add. This method inserts these specified elements into the PriorityQueue. Let's just say PriorityQueue, and this one uses a generic string, a string element. So let me just create an instance of it, priority, and this one is a string. This gives us an instance of it. By default, if you do default constructors, the ordering of the elements that you insert in there is by the natural order. For example, if this is not a string but an integer, then the natural order for integer is 1 is less than 2, less than 3, and so on and so forth. And a negative number is less than 0, right? I want to do a queue add. I'm going to do A, and then PQ, and then PQ, add, and B. This method retrieves elements that was inserted first. So if I do PQ, peek, this one is going to peek into the head of this queue, returning null if queue is empty. I should be getting an A. And then you have Z, and then you have B. The underlying buffer inside this queue is a collection because we're using a collection. This could also be a linked list, right? So let me just go back to my code. This other method that I want to illustrate is called poll, P-O-L-L. This method retrieves and removes the head of the queue or returns null if the queue is empty. Very similar to peek. In addition to peeking into it, it also removes the element on top. So if we do a run, you'll see removed. So A is going to be removed. What you're left with is going to be Z and B. So that's one example. Why don't we instantiate a new queue with a comparison involved? Comparison is part of the comparable, but this one does not have it. We can write another class. So this class would be the comparator instance. Comparator is a interface. You have to override its compare method. Instead of having A, Z, B in the first in, first out, when you insert elements into it, it automatically goes into the ordering mechanism, depending on how your comparator is constructed. Let's just create a nested static class inside this. Let's just call this a queue comparator. This is our custom class that implements comparator. Comparator is part of your Java util. This is the override. And this one is the public integer. Compare in a comparator or compare to in a comparable produces an integer return, either negative, 0, or positive, S1 and string S2. Make use of the string instance itself, a comparable, S2 compare, string implements comparable, right? So you can use compare to S2 If we return this is going to follow the natural order. If S1 is greater than S2 is going to be a positive 1, S1 less than S2, in this case 8, comparing to B, for example, is going to be negative 1. If S1 is the same as S2, it will return 0. We want this to be in descending order. We want to return S1, S2, so on and so forth in descending order. We will multiply this by negative 1, or you can put a parentheses next to it. This comparator is something that we want to pass into it. We want to create an instance of it. So one of the constructors in PriorityQueue takes a comparator, an instance inside of PriorityQueue PQ instance that will make use of the comparator. When we do A, Z, B, it should be Z. When you're inserting A, Z, and B into it, it's also making a comparison. The insertion happens. It checks to see what it has, order these things priority. So now, if you're to insert A into it, instead of having 8 and Z, Z is the second element. The comparator, making use of this comparator, is going to automatically reorder this such that the entire thing will be in a descending order. So instead of having this, Z is now going to be inserted in front of A. Instead of having this, first in, first out, what you end up with is Z, B, A. That would be the order of this, making use of these comparators. You can run a couple of tests and you can do a poll, you can do a remove to check for the order here. So this is an example of custom PriorityQueue with a descending order comparisons built into the instance at construction time.